Welcome. In this video, we are covering everything you need to pass the Pcep, the Certified Entry-Level Python Programmer exam. This is a Python Institute certification that validates your understanding of core Python syntax, data types, control flow, functions, and exceptions. Whether you're a complete beginner or brushing up before the exam, this is your complete study guide. Let's go. Let's start with the exam itself. The Pcep exam code is Pcep 3002. You get 45 minutes to answer 30 questions. The passing score is 70%. That's 21 correct answers out of 30. There are no prerequisites. Anyone can sit this exam, no prior experience required. The question types mix single and multiple choice, fill in the blank, and drag and drop code ordering. It's delivered online through the Python Institute's OpenEDG platform. Look at the domain weights on the pie chart. The single largest domain is control flow at 29%, conditionals, loops, break, continue, range. Then functions and exceptions at 28%, data collections, lists, tuples, dicts, strings, sets at 25%, and computer programming and Python fundamentals at 18%. Together, that's 100%, and together, those four areas cover everything on the exam. The certification pathway diagram shows where Pcep fits. It's the entry point. Pcep leads to Pcap, the Certified Associate. Pcap leads to Pcpp Level 1, then Level 2. Each level builds on the previous. The Pcep is your foundation. Get it right here, and every subsequent level becomes easier. Next. Before we touch any syntax, let's understand what Python actually is. Python is interpreted. Code is executed line by line at runtime, rather than compiled to machine code ahead of time. It's dynamically typed. You don't declare variable types. They're inferred at runtime. It's strongly typed. Even though types are dynamic, Python won't silently coerce unrelated types together. You can't add a string and an integer without an explicit conversion. It's high-level, multi-paradigm, and most importantly, indentation-based. In Python, whitespace is not formatting. Whitespace is the syntax. The source code lifecycle diagram shows what happens when you run a .py file. The CPython interpreter compiles your source to bytecode, stored in .pyc files, inside the _pycache__ directory. That bytecode is then executed by the Python virtual machine, the PVM. You never interact with any of this directly. It all happens automatically. But understanding it explains why Python is slower than compiled languages, and why importing a module the second time is faster. The bytecode is cached. The first program, print. Hello world. The print function has 4 key parameters worth memorizing. Pcep controls the separator between multiple arguments. It defaults to a single space. Int controls what's printed after the last argument. It defaults to a new line character. File controls where output goes. It defaults to standard out. Flush forces the output buffer to flush immediately. The exam tests all 4 of these, particularly Pcep and end. Python has a rich built-in type system. Look at the diagram. Types split into 6 families: numeric, int, float, and complex. Sequence, str, list, and tuple. Mapping, dict. Set, and frozen set. Boolean, bool, which is actually a subclass of int. And none type, the single value, none. Variable naming rules. Names can contain letters, digits, and underscores, but cannot start with a digit. Hyphens are not allowed. That's the subtraction operator. Reserved keywords, like class, for, if, return, cannot be used as names. The Python convention from PEP 8 is lowercase with underscores. My underscore variable, user underscore age. Constants are written in all uppercase. Max underscore size, pi. These are conventions, not rules enforced by the interpreter. Multiple assignment, x equals y equals z equals 0, assign 0 to all 3. Tuple unpacking, ABC equals 1, 2, 3. The swap idiom, a, b equals b, a, completely Pythonic, and works without a temporary variable. Type, returns the class of an object. Isinstance, checks if an object is an instance of a class. Prefer isinstance in real code because it handles inheritance correctly. Explicit type conversion, int, 42, float, 3.14, str 100, bool, 0. Know the falsy values deeply. The exam tests these constantly. 0, empty string, empty list, empty tuple, empty dict, empty set, and none are all falsy. Everything else is truthy. One exception many miss, a string containing only a space, is truthy because it's not empty. Next. Operators are heavily tested on the Pcep. Let's go through each category. Arithmetic, addition, subtraction, multiplication, you know these. The ones that trip people up are the last 3. Slash is true division. It always returns a float. Even 4 halves gives 2.0. Slash is floor division. It divides, and then floors toward negative infinity. Percent is modulo. The remainder is exponentiation. 2 * 10 is 1024. Beat the floor division edge cases. -17/5. You might expect -3, but it's -4. Floor division always floors toward negative infinity, not toward 0. And -17% 5 gives 3, not -2. The sign of the modulo result always follows the sign of the divisor in Python. These are guaranteed exam questions. Beat. Comparison operators. Double equals for equality, equals for not equal. Python supports chain comparisons. 1 less than x, less than 20, is valid in natural Python. Critically, equals tests, value equality. Is tests identity, whether two names point to the same object in memory. A equals 1, 2, 3, B equals 1, 2, 3, A equals B, is true because the values are the same, but A is B, is false because they are different list objects. Never use is to compare values. Beat logical operators, and or not. These use short-circuit evaluation, and stops and returns the first falsy value it finds, or stops and returns the first truthy value. 0 or hello returns hello. Hi and bye returns bye. The result is not always a Boolean, it's one of the operands. Beat operator precedence, the most critical table in the exam. At the top, Pcep, then unary plus, and mines, then asterisk, slash, %, then plus, and mines, then bitwise shifts, then bitwise and, XOR, OR, then comparisons, then not, then and at the very bottom, or. When in doubt, add parentheses. They cost nothing, and make code unambiguous. Next. Conditionals make up part of the largest domain on the exam. Control flow at 29%. Know them cold. If, elif, else. The structure is straightforward. The colon ends each header line. The body must be indented. Once a condition matches, only that branch executes. Subsequent elif and else branches are skipped entirely. Beat. Look at the grade determination example. Score 78. If score greater than equals 90 is false, skip. Elif score greater than equals 70. This is true, so grade equals C. The remaining elif and else are never evaluated. Important. The ordering matters. If you wrote elif score greater than equals 60 before elif score greater than equals 70, a score of 78 would match the 60 check first and get grade D incorrectly. Beat nested conditionals. An if inside another if. The inner condition only evaluates if the outer is true. Use sparingly. Deep nesting is hard to read. Beat. The ternary operator. Python's one-line conditional expression. Status equals adult, if age greater than equals 18 else minor. The value before if is returned when the condition is true. The value after else when false. This is the conditional expression, and the exam tests it frequently. Note the order: expression, then if, then condition, then else, then the other expression. The pass statement, a legal no-op. Use it when a syntactically required code block has nothing to do yet. An empty if block without pass is a syntax error. With pass it's valid. Think of pass as a placeholder that says nothing goes here on purpose. Loops are the exam's single most tested concept, 29% of the entire exam. Know every nuance. The while loop executes as long as its condition is true. The key is that the condition is checked before each iteration. If the condition is false on the first check, the body never runs. Beat, while true, creates an infinite loop. The only way out is break. Break exits the loop immediately, skipping any remaining iterations. Continue skips the rest of the current iteration's body and jumps back to the condition check. Pass inside a loop does nothing. Execution falls through to the next statement. Beat, the while-else construct. This catches candidates completely off guard if they've never seen it. The else block after a while loop runs when the loop condition becomes false naturally, meaning no break was executed. If a break fires, the else is skipped. The for else works the same way. This is a prime exam question. Write a prime number checker where you break if a factor is found, and the else prints is prime if no factor was found. Beat range, critical function. Range n produces 0 through n1. Range, start, stop, produces start through stop -1. Stop is exclusive. Range, start, stop, step, steps through. Range, 10, 0, -1, counts down from 10 to 1. Note, not to 0. Range, 5, 5, is empty, start, equals stop. Range, 5, 0, is also empty. Default step is +1, which never reaches the stop. Beat range is lazy. It doesn't store all values in memory. Wrap it with list to see the contents. It's iterable, supports indexing in len, and supports the in operator. Beat, enumerate, pairs each element with its index, specify start equals 1. to count from 1 instead of 0. Zip pairs elements from 2 or more iterables in parallel. It stops at the shortest iterable. Lists are the most versatile data structure in Python and a cornerstone of the collections domain. Lists are ordered, mutable, and allow duplicate values. They're created with square brackets. You can mix types, integers, strings, floats, booleans, even other lists, all in the same list. Beat indexing is zero-based. The first element is index 0. Negative indices count from the end. -1 is the last element. -2 is second to last. If you go out of bounds, you get an index error. Beat slicing. List, start, stop step. Start is inclusive, stop is exclusive. Omitting start means from the beginning. Omitting stop means to the end. List. -1 is the idiomatic way to reverse a list. Slices never raise index error. Out-of-range slice indices are silently clamped. Beat list methods, the ones to know cold. Append adds one element to the end. Insert, index, value, inserts at a specific position. Extend adds all elements from another iterable. Remove, value, removes the first occurrence, raises value error if not found. Pop removes and returns the last element. Pop index removes at a specific index. Sorts in place. It modifies the list and returns none. Don't assign lst equals lst sort, you'll get none. Sorted returns a new sorted list without modifying the original. Reverse reverses in place. Count value counts occurrences. Index value returns the first index. Beat list comprehensions, expression for item in iterable, if condition. The condition is optional. These are the Pythonic way to build lists, and are faster than equivalent loops. Know the syntax precisely. The exam uses fill-in-the-blank questions on comprehension syntax. Tuples look like lists, but behave fundamentally differently. They are immutable. Once created, you cannot change a tuple's elements. No append, no remove, no item assignment. Attempting any of these raises a type error. Beat creation syntax, parentheses with comma-separated values. The single-element tuple trap, 42, is just the integer 42 in parentheses. 42 is a tuple containing 42. The comma is what makes it a tuple, not the parentheses. This is one of the most common exam questions. You can even write 42 with no parentheses. That's also a valid tuple. Beat tuples support all the same read operations as lists: indexing, negative indexing, slicing, len, in, plus concatenation, asterisk repetition. Tuples have exactly two methods: count and index. That's it. Beat tuple unpacking. Assign multiple variables at once from a tuple. XYZ equals 1, 2, 3. Extended unpacking with the star operator. First, rest equals 1, 2, 3, 4, 5. First gets 1, rest gets the list. 2, 3, 4, 5. Daksha head, last, gives you everything, except the last element. Beat why use tuples. 4 reasons. Immutability. Protect data from accidental modification. Performance tuples are faster than list to create and iterate. Hashability. Tuples can be dictionary keys and set members because they're immutable. Semantic meaning. Coordinates. RGB values. Database records are naturally fixed length, fixed structure data that tuples express perfectly. Dictionaries store key-value pairs. They're ordered from Python 3.7 onwards, mutable, and keys must be unique and hashable. Creating a dict, curly braces with key, value pairs. The dict, constructor alternative. Dict, name equals Alice, age equals 30, or dict, A1, B2, from a list of pairs. Beat, accessing values, square bracket notation D key, raises a key error if the key doesn't exist. .get key, returns none if missing, no exception. .get key, default, returns the default value if missing. Prefer .get, when you're not sure a key exists. Beat, adding a new key is the same syntax as modifying an existing one. D, new underscore key, equals value. If the key exists, the value is updated. If not, it's created. Del D, key, removes a key value pair. Key error if not found. .pop, key, removes and returns the value. Beat, the 3 iteration methods, keys, returns a view of all keys. .values, returns a view of all values. .items, returns a view of all key value pairs as tuples. Membership testing with in checks keys by default. Alice in person checks if Alice is a key, not a value. To check values, use Alice in person.values. Beat .update, merges another dict, existing keys are overwritten. .set default, key, default, returns the value if the key exists, or inserts the default and returns it if not. The Python 3.9 plus merge operator merges 2 dicts into a new one without modifying either. Beat, dict comprehension, KV for K, v in items.items, if condition. Same filtering and transformation power as list comprehensions, but produces a dict. Sets are unordered collections of unique elements. Duplicate values are automatically removed. They're mutable, but their elements must be hashable, so no lists inside sets. The critical creation gotcha creates an empty dictionary, not a set. To create an empty set, you must use set. 1, 2, 3 is a set literal that works, but alone is always a dict. Beat sets are unordered. There is no indexing. My underscore set 0 raises a type error. Membership testing within is 01. Constant time regardless of the set size. This is the primary reason to use a set over a list for lookups. Beat set operations map directly to the mathematical set operations you may know. Union, AB or A union B, all elements from both sets. Intersection, A and B, only elements in both. Difference, AB, elements in A but not in B. Symmetric difference, A caret B, elements in one set but not both. Beat set relationships, is subset, and the less than equals operator check whether all elements of one set are contained in another. Is superset, and greater than equals go the other direction. Is disjoint, returns true if the two sets share no elements. Beat, add, adds one element. Update, adds multiple. Remove, raises a key error if the element isn't present. Discard, silently does nothing if the element isn't there. Prefer discard when you're uncertain. Beat frozen set is the immutable hashable version of a set. It supports all the same set operations but cannot be modified. Because it's hashable, a frozen set can be used as a dictionary key or stored inside another set. Ext. Strings are one of the most tested data types on the Pcep. They're immutable sequences of characters. For creation, single quotes, double quotes, triple quotes for multi-line strings. Raw strings are. Treat backslashes literally, so rn is 2 characters, backslash and n, not a new line. Useful for file paths and regular expressions. Beat, escape sequences, n new line, t-tab, literal backslash, and for quotes inside strings. Know all of these. The exam will show escape sequences and ask what the output is. Beat, string formatting, 3 methods, and you need all 3. F-strings, preferred, Python 3.6 and above. Embed expressions directly. fname.upper, fpi.2f, f42, 08b, str.format, hello.format, name, or with named placeholders, name.format, name equals name. Percent formatting, hello, %s %name, older style, but still on the exam. Beat formatting specifiers in f-strings are worth memorizing. .2f, 2 decimal places. 10, minimum width 10. Greater than 10, right a line in width 10. Less than 10, left a line. Caret 10, center. 08d, 0 pad integer to 8 digits. Hash x hex, with 0x prefix. Hash b, binary with 0b prefix. Score equals, the equals sign inside the braces, prints both the expression and its value, a debug shorthand. Beat strings are immutable. 0 equals, j raises a type error. You build new strings by concatenation, or slicing. Strings support indexing and slicing, exactly like lists and tuples. Beat string methods, the exam tests these heavily. Upper, lower, title, capitalize, swap case, for case. Strip, lstrip, rstrip, for removing whitespace or specific characters. Find, returns -1, if not found. Index, raises value error, if not found. Replace, returns a new string. Remember, strings are immutable. Split, on a delimiter. Split, with no argument splits on any whitespace and removes empty strings. Join, is the reverse. Join, ABC, gives ABC. The testing methods, isalpha, isdigit, isulnum, ispace, isupper, islower. Ext. Functions are 28% of the exam, the second largest domain. Define a function with def, the name, parentheses, a colon, and then the indented body. The return statement sends a value back to the caller. A function without return implicitly returns none. Default parameters, def power, base, express equals 2, lets you call power 3 and get 9. Default values are evaluated once, when the function is defined, not each time it's called. This leads to a famous trap, a mutable default like a list. We'll cover that in the traps slide. Beat, multiple return values, Python returns a tuple. Return min, lst, max, lst, returns 2 values. Use tuple unpacking, low, high equals min underscore max. Beat, keyword arguments, you can pass arguments by name, regardless of order. Describe, age equals 25, name equals Bob. The parameter names make it self-documenting and order independent. Mix positional and keyword. Positional must come first. Beat collects any number of positional arguments into a tuple. Noct co-remains collects any number of keyword arguments into a dictionary. These let you write functions that accept a variable number of inputs. Beat scope. The LEGB rule, local, enclosing, global, built-in. When Python looks up a name, it searches in this order. Local first, the current function's namespace. Then, enclosing any outer function, if this is a nested function. Then global, the module level. Then, built-in, the Python built-ins like len, print, range. The global keyword lets you modify a module-level variable from inside a function. The non-local keyword lets an inner function modify a variable in its enclosing function, used enclosures. Beat lambda, anonymous single expression function. Lambda x, x***2, is equivalent to a def that returns x***2. Lambdas are commonly used with sorted, map, and filter, where you need a short function in line. Comprehensions are the Pythonic way to build collections from iterables. They're concise, expressive, and faster than equivalent for loop code. List comprehension syntax. Expression for item, in iterable, if condition. The condition is optional. Without a condition, every element is transformed. With a condition, only elements that pass the filter are included. X** and in a 2, for x in range 10, if x%2 equals 0, gives you the squares of all even numbers from 0 to 9. A common exam trick. The placement of the condition changes meaning completely. EXPR, if cond else other for item in iterable. The conditional expression before for transforms every element, choosing between two values. EXPR for item in iterable if cond. The condition after, for filters elements. These look similar, but behave differently. Know the difference. Beat nested list comprehension. Elem for row and matrix for elem in row, flattens a 2D list. Read from left to right, the outer for first, then the inner for. This is exactly how it would look if you wrote nested for loops, just compressed onto one line. Beat set comprehension. Same syntax, curly braces instead of square brackets. Result is a set, no duplicates, unordered. x***2 for x in 1223 gives 149. Dict comprehension. Key _expr, value _expr for item in iterable. Building a name to length mapping. Name, len, name, for name in names. Inverting a dict, vk for k, v in original.items. Beat generator expressions. Same syntax as list comprehensions but with parentheses. The critical difference. They are lazy. Values are produced one at a time on demand, not all at once. x***2 for x in range, 1000, uses about 104 bytes. The equivalent list comprehension uses approximately 8,800 bytes. When you only need to iterate once, like passing to sum or max, use a generator expression. No extra list needed. Sum, x***2 for x in range, 100. Ext. Exceptions are Python's mechanism for handling errors gracefully. Without exception handling, any runtime error terminates your program. With it, you can detect, react, and recover. The try except block, code that might fail, goes in try. If an exception occurs, execution jumps to the matching except block. Code after the point of failure in try is skipped. Beat catching specific exceptions. Except value error handles only value error. Except value error type error handles either. Except exception has E captures the exception object in E. You can print its message with STRE. Catching except exception broadly catches most non-system errors. Catching bare except catches everything including system exit and keyboard interrupt. Avoid this. The else clause. This block runs only if the try block completed without raising any exception. Use it for code that depends on the success of the try block. This makes the code's intent clearer than putting success path code inside the try. The finally clause. This block always runs, regardless of whether an exception occurred or was handled. Use it for cleanup. Closing files, releasing locks, closing database connections. Even if you return from inside the try, the finally runs first. Beat, raising exceptions. Raise value error message, triggers an exception manually. Use this to validate inputs and signal bad conditions. Raise with no arguments inside an except block. Re-raises the current exception, useful for logging, then propagating. The exception hierarchy diagram. Understand the tree structure. Base exception is at the top. Everything in normal code inherits from exception. System exit and keyboard interrupt sit outside exception. That's why catching bare except exception doesn't catch Control-C. Arithmetic error covers zero division error and overflow error. Lookup error covers index error and key error. When you catch lookup error, you catch both. Beat custom exceptions. Subclass exception. Call super __init__ with the message and add whatever attributes are useful. Custom exceptions make your APIs self-documenting. Callers know exactly what errors to expect and what data they carry. A module is simply a Python file. When you import it, Python executes the module file and makes its names available in a namespace. 4 import styles. Import math. Use everything with the math prefix. Import math as m, alias the module name. From math, import sqrt, pi. Import specific names directly, no prefix needed. From math, import asterisk. Import everything. Avoid in production, because it pollutes the namespace with potentially hundreds of names. The underscore name, underscore, equals, underscore main idiom. When Python runs a file directly, it sets underscore name, underscore to underscore main, underscore. When a file is imported as a module, underscore name, underscore is set to the module's file name. This pattern lets you write code that runs only when executed directly, your test code, your main call, and not when the file is imported by another script. You will see this on the exam. Beat random module, random, returns a float in 0.0, 1.0. Randant, AB, returns an integer. Note, both ends are inclusive. Choice, picks a random element from a sequence. Shuffle shuffles a list in place. Sample, returns a list of unique random selections. Beat platform module, Python underscore version, machine, system. The SYS module, SYS version for the full version string, SYS.path for the module search path, SYS.exit, code, to exit with a return code. The module search diagram. When you import, Python first checks the SYS.module's cache. If already imported, the cached version is returned. If not, it searches SYS path, which includes the current directory, Python path, and the standard library locations. If it finds the file, it compiles to bytecode and executes. If not, module not found error. Next, we covered print basics earlier. Let's go deeper on formatting, then cover file I/O. The format specifiers and f-strings are tested directly. Pi.2f. .2f means 2 decimal places, f for float. Pi 10.3f. Total width 10, 3 decimal places. 1,234,567, 1,000 separator. 42, 08d. 0 padded to 8 digits. High, greater than 10, right aligned in 10 characters. High, less than 10, left aligned. High, 10, centered. 255. Hash x, hex, with 0x prefix. Beat input, always returns a string. If you need a number, you must explicitly call int, or float on it. If the user types something that can't be converted, you get a value error. Always wrap numeric input parsing in a try, except block in real code. Beat file I/O, the open function. The first argument is the file path. The second is the mode. R for reading, this is the default. W for writing, this truncates the file if it already exists. A for appending, creates file if it doesn't exist, adds to the end if it does. X for exclusive creation, raises file exists error if the file already exists. Add B for binary mode. Beat 3 ways to read. F.read, reads the entire file as one string. F.readline, reads one line at a time. F.readlines, reads all lines into a list. Each line includes the trailing new line character. Or iterate over the file object directly in a for loop. This is the most memory-efficient approach for large files. Beat the with statement, always use with open, when working with files. The with block automatically closes the file when the block exits, even if an exception is raised inside the block. Without with, you must remember to call f.close, manually in a finally block, or risk file handle leaks. The with statement is Pythonic, and the exam expects you to know it. Next, Python provides several built-in functions that apply functional programming patterns, processing collections without explicit loops. Map, function iterable, applies a function to every element, and returns an iterator. List, map, lambda xx, asterisk 2, nums, squares every number. You can pass a regular named function instead of a lambda. List, map, int, string underscore numbers, converts a list of strings to integers in one line. Map, with multiple iterables. Map, lambda x, y, x plus y, a, b, adds pairwise elements from 2 lists. Beat filter, function iterable, keeps only elements where the function returns true. List, filter, lambda xx greater than 0, nums, only positives. Filter, none, collection, is a shorthand for removing all falsy values. Zeros, empty strings, none, empty lists, all removed in one pass. Beat combining map and filter creates a pipeline. List, map, lambda xx asterisk 2, filter, lambda xx% 2 equals 0, range 10, filter to evens, then square each. List comprehension is usually more readable for this. x asterisk 2 for x in range 10, if x%2 equals 0. Both approaches are valid. Pcep creates an iterator of tuples pairing elements, stops at the shortest iterable. The unzip pattern, zip, pairs, transposes a list of pairs, past the list of pairs with the star operator, and zip pairs up the first elements, then the second elements, effectively transposing rows and columns. Sorted returns a new sorted list without modifying the original, takes a key parameter, a function applied to each element before comparison. Sorted words, key equals len, sorts by string length. Sorted words, key equals lambda w, w-1, sorts by last character. Reverse equals true for descending order. All and any all returns true if every element is truthy. Any returns true if at least one element is truthy. Both short circuit, all is true, vacuous truth. Any is false, no elements to be true. Both work beautifully with generator expressions. Next. This slide is pure exam preparation. Every item here is a trap that regularly fools candidates. Go through each one carefully. Float precision, 0.1 plus 0.2 does not equal 0.3 in Python. It gives 0.3000000000000000004. This is IEEE 754 floating point arithmetic, not a Python bug. Every language with hardware floats has the same issue. Never compare floats with equals. Use abs, AB, less than 1 E9 instead. Beat floor division and modulo signs, 7/2 is 3. -7/2 is -4, not -3. Python always floors toward negative infinity. -7% 3 is 2, not -1. The modulo result carries the sign of the divisor. These floor and modulo edge cases with negative numbers appear on almost every Pcep exam. Beat mutable default argument, the most famous Python gotcha. Def_append, item, lst equals. The default list is created once when the function is defined and reused on every call. Call it 3 times and the list keeps growing. The fix, use none as the default and create a new list inside the function if lst is none. Beat list aliasing. B equals A does not copy the list. Both A and B point to the same list object. Appending to B modifies A. To get an independent copy, use B equals A.copy or B equals A. For nested lists, use copy.deepcopy. Beat single element tuple, 42, is an integer. 42 is a tuple. The comma is the tuple maker. This will be on your exam. Guaranteed. Beat is versus equals equals. C Python caches small integers, roughly -5 to 256. This means A equals 256, B equals 256. A is B returns true. But A equals 1000, B equals 1000. A is B returns false. They're different objects. The values are equal but not the same object. Use equals for value comparison, always. Never rely on is for numbers or strings in regular code. Beat loop variable persistence. After a for loop completes, the loop variable still exists in the local scope with the last value it held. For I in range, 5, pass after the loop, I is 4. This is intentional Python behavior but surprises beginners. Beat modifying a list during iteration. If you remove elements from a list while iterating over it, you'll skip elements because the indices shift. Always iterate over a copy, for X in LST, when you need to modify during iteration. Let's cover strategy and the quick reference points that you must know on exam day. The most tested topics, roughly in priority order. Operator precedence, specifically asterisk first, then unary, then asterisk per percent, then plus, and the fact that OR is the lowest. Floor division and modulo with negatives. The single element tuple comma is versus equals, string methods and their return values. List methods that return none versus those that return a value. The for else construct, an input, always returns a string. Beat, look at the quick reference table. The immutability summary, str, int, float, tuple, are immutable. List, dict, set, are mutable. This affects what you can do with them, whether they're hashable, and whether they can be dict keys. The mind map shows all 4 domains radiating from the center. Fundamentals, data types, variables, print, input, conversion. Control flow, if elif/else, while, for, break, continue, range. Collections, lists, tuples, dicts, sets, strings, comprehensions, functions, parameters, scope, lambda, exceptions, modules. Beat exam day strategy. You have 45 minutes for 30 questions. That's 90 seconds per question. Most questions can be answered in 20 to 30 seconds. Flag complex ones, and return. For code tracing questions, trace on paper, line by line. Don't try to hold 6 variable values in your head simultaneously. Beat, for operator precedence questions when you're unsure, parenthesize mentally. Replace 2 plus 3 asterisk 4 internally with 2 plus 3 asterisk 4 and reevaluate. For is versus equals questions, equals is almost always the correct answer unless the question specifically asks about object identity. Next. The mind map on this slide captures the full Python Essentials skill tree. 8 branches: syntax, types, operators, control flow, functions, exceptions, and modules. Every branch connects to every other. Let's close with the 10 rules for exam day. Click Rule 1. Input always returns str. Every time. No exceptions. Convert explicitly. Click Rule 2. 42 is a tuple. 42 is an int. The comma is the tuple maker. Click Rule 3. Floor division, /floors toward negative infinity, not toward 0. -7/2 is -4. Click Rule 4, is compares identity, equals compares value. Use equals for all value comparisons. Click Rule 5, mutable defaults and functions are shared. Use none as default, create inside. Click Rule 6, for else fires when no break occurred. It's not else after for, it's else if loop completed normally. Click Rule 7, dict preserves insertion order from Python 3.7. Click Rule 8, sets are unordered and unindexed. No set. Use in for membership. Click Rule 9, range is lazy. Rep with list to see values. Range 5, 5, and range 5, 0 are empty. Click Rule 10, print AB adds a space by default. Change it with Pcep equals or any other separator. Next. And that is the complete Pcep study guide. Every domain, every major concept, and the traps that trip people up most often. Practice these topics daily. Code in the Python REPL. Trace programs by hand. Take the official Python Institute sample tests before exam day. If this video helped, please like and subscribe for more Python and certification content. Good luck on your Pcep. See you in the next one.